Hi there! In this episode we will continue with the catamaran build, and today I'm going to start building the front cross beam, connecting this hull with the hull that I have already made. I want a lightweight cross beam that is easy to carry down to the beach. But I also want a strong cross beam that will carry my weight and any passenger weight, but also the variable forces from the sailing. So a strong and lightweight crossbeam is that we are going to try to build today.
I used my previously built cutting board to rip a 45mm wide plank into 10mm thick strips. These will be the base material for my build. If I glue several strips together, I can even out weakness from knots and imperfections in the wood, thus reduce the safety margin needed in the strength calculations. I will also need some strips that are thinner than 45mm, so I prepare to rip up some of the 45mm wide strips into 10 x 10mm strips with some sanding margin. What is left over from the 45mm thick strip when I have ripped off the free 10mm strips will also be used. I finish with sanding down any unevenness from the cutting, and so that the strips are even and ready for gluing. I plan on building an arch-formed crossbeam. This will add about 10% strength compared to a straight crossbeam. I have saved the bending mold from my first catamaran build. After putting new masking tape on it, I will be able to reuse it. The masking tape will prevent the strips from being permanently glued to the mold. To further reduce weight while retaining as much strength as possible, I will make the beam hollow. I will make the core of the side walls first. Thus I glue 4 strips together that are 10mm wide and 10mm high. To avoid getting glue all over the place, I glue one side of the strips at a time and put them together 2 and 2. Put some more glue on the back sides before I put the 2 pairs together to the full stack. Now I can start forming the arc. I work from the middle and outwards. This gives me best control over the bending process. I wipe off the excess epoxy and inspect that there are no wide gaps. The next day I can remove the clamps. One arc won't be strong enough. I will need more material to reach my target strength. I'm aiming for a crossbeam that can take at least a weight of 160 kg. So I prepare strips for a second wall and thickened epoxy to wet these and pair them to a full stack and press these to shape. These 2 arcs would probably carry 30 kilos, so I need to add more material. I will do this at the top and bottom to form an O-beam. The bottom and the top of the O-beam might be harder to shape. These are also more important, as these will carry more over the forces. When a force is acting on a beam from above, it bends, and the forces are not evenly distributed. At the top and the bottom, the length difference is the largest, and that is where the compression and tension forces are the largest. I will glue the strips together and let them cure on the bending mold, to make it easy to later glue them to the arc core. To not spill too much epoxy, I put glue on the bonding sides before I press the 2 sides together. I will need 4 sets of strip pairs, 2 for the bottom and 2 for the top, making up a total width of about 165mm. This will increase the strength to about 210 kg. When I have pressed the pairs together, I put some glass on the seam. This will make the seam temporarily stronger. Now I will start shaping the strips to the mold. Having aligned the seam over the mold, I can shape both strips in pair together. I put plastic on top of the first pair and put the second pair on top. so that I can put some glass on this seam as well. Then I start shaping the second pair on the top of the first pair. Now I can start adding the third pair. When all 4 pairs of strips are pressed against the mold, I can let them cure. Now I get back to the side cores instead. I want these flat, smooth and even, so that I can draw their shape onto the 2 somewhat wider strips. I will phase these wider strips into transformation layers, where the core wall meets the top and the bottom. That will increase the strength to about 980 kilos. Now I can move inside again to put on the transformation pieces. I put masking tape around what will be the seam. The plan is to keep the epoxy in the gap. Then I put thickened epoxy on the bonding sides and press the pieces against the already bent core. I press a new addition towards the core with clamps and make sure that the new pieces is level with the core. I add the transformation pieces to both cores at the same time. The day after I have some spillage to take care of. I remove the masking tape with a window scrape and the rest with sanding until the surface is smooth again. I can as well trim off the excess length. On the inside again I can let loose the top and the bottom pieces. They didn't bend much. At least I haven't introduced any new resistance towards bending during gluing. But I wouldn't recommend another builder to redo it in this way. It adds too much work for almost no gain. I need to make the pairs level with each other, although most of the glass will be lost in the process. So the only benefit was the epoxy between the strips that is pre-bent to shape. Inside I have dry fitted the assembly of the crossbeam. I take it apart so that I can start putting the things together. The masking tape will keep the bottom pieces together during gluing and also prevent epoxy from dripping out. I put extra thick glue on where the sides will be. Put the side in place and a solid piece where the mast foot will be. When I have located the pieces in relation to each other, I can start pressing everything together and add temporary support to level out the bottom, as well as securing the ends and also the bottom. I finish with putting some glass between the clamps to secure the still weak middle seam. A few hours later I'm back, and with a little tilt of the beam I can put glass on the side wall. I want to do this before the bottom has cured to reduce the need for in-between sanding. The tilt makes it easier to wet out the cloth. I also put glass on the side of the mast foot support. A few more hours and I'm back tilting to the other side and putting glass on this side as well. The next day all has cured and I can clean up the edges. Check what hasn't worked so well. The bending isn't even in the beam. Will it fit? Sort of. I can trim down the ends, so those doesn't interfere with the fitting. There is about an 1 centimeter gap and a bit of wobbling. While I think about how to cope with this, I can do some fine trimming. Cutting down the length to 205 centimeter. Sand the inside and the outside. And move inside for glassing in the inside. The glass I put on before was only to keep the seam together. Now I need to glass all to also cover the places where I had clamps. This is mostly to make the inside watertight, but the glass will also add a little strength, where it makes most use. That is in the bottom of the beam, where it increases the tension strength. In the ends I put double layers on the sides, as my construction will have more wear and tear here. To prepare for putting the top of the crossbeam in place, I need to transfer the position of the mast foot to where it's visible after having put on the top. I write the distance to the center on the side. I prepare the glass I need on the inside of the top, pre-wet the surface and lay down the glass. When all is well wetted out, I have put extra thick epoxy on the edges, also on the receiving end. I use up the excess to smoothen out the surface before I put down the beam on the top cover and start clamping the box together. I need to control the gaps, both along the beam and the cross. After a while I have used a lot of clamps. You can never have enough clamps. The next day I can proceed with finding the mast foot hole. Looks like I found it. Exactly. Outside I can level the outside of the beam. I finish with rounding the edges. The worst unevenness can't be sanded. I would lose too much strength. Instead I will add light material on the low side. I will also add some material to the beam supports. At the same time I glass in the bottom. Here I put down 300 grams per square meter biaxial glass. This will add strength at the most important place. The glass has a much higher tensile strength than wood, about 10 times larger. Now my beam will be able to carry 110 kilos before it breaks. I glue on the addition to the beam support. This will give me material to cut away so that I can get a level support surface. I finish with clamping. A few hours later I'm back to refill the cloth. The next day I can add the material on the other side. The day after I can remove the clamps, head outside for some sanding. Having a flat surface I can glass in the top side and after fill the cloth. The beam supports needs to be sloped differently, so there are some sanding to do. Improvement and no wobbling. I put glass on the new surface for the beam support. I glass in the sides of the beam with the 300 per square meter glass fiber. Now I have a watertight front crossbeam that will carry me and 1 metric ton of other stuff before it breaks. In the next episode I will put on the mast foot and the stepping device for the mast. Please join me then.